In this episode, we're going to focus on file operations in Linux and, more importantly, the safety habits that keep those operations from turning into accidental disasters. New learners often assume that creating, moving, copying, and removing files are basic actions that behave the same everywhere. But Linux brings a few extra layers that matter, like permissions, ownership, links, and the difference between a file's name and the data it points to. The Linux Plus exam likes these topics because they are foundational, but it also likes them because a small misunderstanding can lead to big consequences, which means careful thinking is part of the skill. We are going to treat these actions as decisions you make, not just things you do, and we'll keep the focus on understanding what happens conceptually. When you can visualize what the operating system is actually changing, you can predict outcomes and avoid common pitfalls. That mindset is what makes these tasks feel calm and controlled instead of risky and stressful. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Before we dive into each operation, it helps to adopt one core principle that makes Linux file work safer. A file operation changes names, locations, and metadata as much as it changes content, and sometimes it changes only those things. People often say they are moving a file, but what they really mean is they want a different path to refer to the same content, and Linux accomplishes that with file system rules that can be surprisingly efficient. Other times, the content really is duplicated, and that has implications for disk usage and for later changes. The exam can test this indirectly by describing outcomes like the original file still exists, or changes made after a copy do not appear in the original, or a moved file seems to disappear from one directory but remains open in a running program. These scenarios become easy when you distinguish between data blocks, metadata, and directory entries. If you treat file operations as changes to references within a file system rather than as magical movement of objects through space, you will make fewer assumptions and more accurate predictions. Creating files sounds like the simplest operation, but beginners should understand that creation is really about allocating a new file system object and giving it a name within a directory. That means creation always interacts with permissions, because the ability to create a file is not determined by the file that does not exist yet, but by the directory you are creating it in. If you can write to a directory, you can typically create new entries there, while if you cannot, creation will fail even if you have permissions elsewhere. Creation also interacts with the idea of default permissions, because new files and directories often start with a baseline set of permission bits influenced by system policy and user settings. Another beginner misunderstanding is thinking that creating a file automatically means writing content, when creation can also mean producing an empty object that will be filled later. When exam questions mention not being able to create a file in a location you can read, the correct thought is directory permissions and ownership, not whether the file system has enough free space alone. Treat creation as a directory-level privilege and a metadata event, and it becomes easier to reason about. Copying is where many Linux misconceptions show up, because copying can preserve content while differing in metadata and identity. Conceptually, a copy operation creates a new file system object with its own inode and its own data blocks, even if the content starts out identical. That means after a copy, there are two separate objects that can change independently, which is important for troubleshooting because changing one does not change the other. Beginners sometimes expect a copy to behave like a reference, where updates are shared, but that is a different concept than copying. Copying also raises questions about what should be preserved, such as permissions, ownership, and timestamps, because sometimes you want the copy to behave like a faithful replica, and sometimes you want it to behave like a new file with default attributes. The exam often tests this by describing a copied script that no longer runs due to missing execute permission, or a copied configuration file that now belongs to the wrong owner. Safe copying habits come from explicitly thinking about what needs to be preserved for the copy to function as intended. When you see copying as creating a new identity, you naturally check metadata rather than assuming the copy is identical in all ways. Copying directories adds another layer because the operation is no longer a single object but a tree of objects, and trees can contain a mix of files, subdirectories, and special items. A safe mental model is that a directory is a container of names that point to other objects, and copying a directory means reconstructing that container and all its contents in a new location. That reconstruction can be shallow or deep depending on how the copy is performed, and what matters for exam reasoning is that recursive copying is an explicit concept in Linux rather than an automatic assumption. Beginners sometimes attempt to copy a directory and are surprised when only the directory entry is created without its contents being duplicated, which leads to incomplete results. Another common issue is overwriting, because copying into an existing directory can merge content in ways that are hard to undo if you are not paying attention. The safe approach is to treat directory copying as a planned action, where you first confirm the destination is what you think it is, then consider whether you want to merge, replace, or create a separate sibling directory. The exam wants you to recognize that directory structure magnifies the consequences of a mistake. Moving is often assumed to be a slow copy followed by a delete, but inside a single file system, it is usually much simpler than that. Conceptually, moving within the same file system is typically a rename operation, where the directory entry changes so that a different path points to the same underlying object. The file's content does not have to be duplicated, which is why moving can be very fast even for large files. This also explains why permissions and ownership usually do not change when you move a file within the same file system, because the underlying object is the same. The beginner misunderstanding appears when a move crosses file system boundaries, such as moving from one mounted file system to another, because then the system cannot simply rename a directory entry in place. In that case, the move behaves more like a copy plus a remove, which can take time and can introduce differences in metadata if not handled carefully. Exam scenarios that describe a move taking unexpectedly long or changing attributes are often hinting that the move crossed file systems. The safe mental habit is to ask whether the source and destination are on the same file system, because that determines what move really means. Moving directories requires the same tree awareness as copying, but with a different risk profile, because moving changes where existing paths point rather than creating new duplicates. When you move a directory, everything under that directory moves with it in terms of path, which means any scripts, configurations, or references that expect the old path can break immediately. Beginners sometimes focus on the contents and forget that other things might refer to the path, such as application configurations, environment variables, or scheduled tasks. In Linux, paths are meaningful in a very literal way, and many systems are built on expected directory structures. This is why safe moving includes thinking about who or what might be using that directory, not just whether the files can be moved. Another subtle point is that moving a directory inside the same file system is usually just an update to directory entries, but across file systems it becomes a copy of an entire tree, which can be both slow and error-prone. If an exam question describes moving a directory and then losing permissions or ownership, it is often testing whether you understand the difference between renaming inside a file system and recreating objects in a new file system. The safest mindset is that moving is not only about relocation, it is about changing all future references. Removing is the operation that most demands safety habits, because removal in Linux is often immediate and does not behave like a reversible trash can by default. Conceptually, removing a file means removing the directory entry that points to it and reducing the reference count to the underlying object. If that reference count reaches 0 and no process is holding the file open, the file system can free the data blocks and the inode, making the space available again. This is very different from systems that move files into a special recycle bin automatically, which can create a false sense of safety for beginners. Another important point is that removing a name is not always the same as erasing data instantly, because data can persist until overwritten, but from an operational perspective the file is gone for normal access. Safe removal starts with slowing down and confirming you are targeting the correct path, because the system will not ask whether you are sure in many contexts. Exam questions often test removal safety through scenarios involving wildcard expansion, directory recursion, and unintended targets. The best defense is a mental habit of verifying scope before acting. Removing directories is a special case because directories can contain other objects, and removing them safely requires you to think about whether you are removing an empty container or an entire tree. Linux tends to treat removing an empty directory differently from removing a directory that contains files, because deleting a non-empty directory is a much larger action. Beginners are sometimes surprised that removing a directory can fail simply because it is not empty, and that failure is actually a safety feature because it prevents accidental loss of many files when you intended to remove a single container. The dangerous counterpart is recursive removal, where the system is instructed to delete a directory and everything beneath it, which can wipe out large areas of a file system quickly. Even without focusing on exact commands, the concept matters. Recursion is a multiplier, and you should treat it as a deliberate choice rather than as a convenience. Another common pitfall is confusing relative and absolute paths, which can cause you to remove content from a different directory than you intended because your current working directory was not what you thought. The safest approach is to build a habit of confirming where you are and what your target path resolves to before any destructive action. Linux Plus questions often reward that cautious, path-aware thinking. A major safety theme across create, copy, move, and remove is the importance of understanding overwrite behavior, because overwriting can silently destroy data if you do not anticipate it. When you copy a file into a destination where a file with the same name already exists, the new content may replace the old content, and if you did not intend that, your original may be lost. Similarly, moving into a destination that already contains a same-named file can produce replacement behavior or errors depending on the situation and environment, and this inconsistency is exactly why beginners get surprised. The exam often frames this as a question about preventing accidental overwrite or preserving an existing file when copying a new version. Safe habits here include choosing distinct destination names when you are not sure, using staging directories to confirm results before replacing anything important, and thinking of replacement as a separate decision rather than an automatic side effect. Overwrite risk is also higher when you are operating on multiple files at once, because one unintended match can overwrite a critical file while you are focused on the larger batch. When you slow down and mentally separate the idea of moving content from the idea of replacing existing content, you reduce the chances of a silent mistake. That mental separation is a core exam skill because it reflects real administrative caution. Another critical concept is wildcard matching and pattern expansion, because pattern-based selection can turn a small operation into a broad one faster than a beginner expects. The shell can expand patterns into multiple file names before the operation even begins, which means the tool you are using might not know you typed a pattern at all, because it receives a fully expanded list of files. This becomes dangerous when the pattern matches more than you intended, or when it matches nothing and the behavior differs from what you expect. Beginners often trust patterns too quickly, assuming they match only visible files or only files with a certain extension, and they forget that hidden files, unexpected naming, and directory context can change the match set. This is one of the most common reasons for accidental deletion or accidental copying of too many files. In safe file operations, pattern thinking means you first predict what the pattern will match in the current directory context, and you treat any uncertainty as a signal to verify before proceeding. Linux Plus questions often test this indirectly by describing a batch operation that affected unexpected files, which is a clue that pattern expansion and directory context were misunderstood. When you remember that patterns are expanded before actions happen, you interpret these scenarios more accurately. Links add an additional safety dimension because they blur the beginner assumption that a file name uniquely represents a file. A hard link is another name that points to the same underlying inode, meaning two different directory entries can refer to the same data. A symbolic link is a special file that points to a path, meaning it is a reference to another name rather than another name for the same inode. These distinctions matter for copying, moving, and removing because you might think you are operating on a separate object when you are actually operating on a shared one, or you might copy a link and end up with a link rather than a copy of the target content. Removing a link might remove only the link name while leaving the target untouched, which can surprise beginners who thought they deleted the real file. Conversely, removing one hard link name does not necessarily delete the file content if other hard links exist, because the content remains until the last link is removed and no process is holding it open. Linux Plus questions often include links because they test whether you understand file identity beyond names. Safe habits include recognizing that paths can be references and that you should be aware of whether you are manipulating a link itself or the target object the link points to. When you incorporate link awareness into file operations, fewer outcomes will feel mysterious. Permissions and ownership are the constant background rules that shape whether file operations succeed and what their results look like. So safe work includes predicting permission outcomes. Creating depends heavily on directory permissions, while copying and moving depend on read access to the source and write access to the destination directory. Removing depends on write permissions on the containing directory as well, which surprises beginners who assume removal depends only on the file's own permissions. This is a key Linux concept. The ability to delete a file is usually controlled by the directory that contains it, because deleting is really removing a directory entry. Copying can also be influenced by whether you can preserve metadata, because preserving ownership might require elevated privileges, and otherwise the copy might be owned by the user performing the copy. These differences matter because they can change whether a copied configuration works, whether an executable remains executable, or whether a moved file is still accessible to the intended user. Exam scenarios that mention access denied errors during file operations are often testing whether you know which permission applies, the files or the directories. The safe mindset is to think like the file system. Directories control naming and deletion, files control reading and writing content, and ownership controls who can do which of those things. When you map operations to these rules, you avoid confusion and make consistent predictions. It's also worth developing a sense for verification, because safe file operations are not complete until you confirm the result matches your intent. Verification does not mean memorizing a set of commands. It means checking the right properties based on what you tried to accomplish. If you copied a file to preserve its behavior, you care about content, permissions, and ownership, not just whether the file exists. If you moved a file to reorganize, you care about whether the new path is correct and whether anything still points to the old path. If you removed something, you care about whether the target is truly gone and whether you accidentally removed more than intended, especially when patterns or recursion were involved. Beginners sometimes skip verification because the system does not complain, but silence is not the same as success, especially with overwrite scenarios. Linux Plus questions often imply verification by describing that a system behaves incorrectly after a file operation, which suggests the operation completed but produced an unintended state. The core lesson is that file operations are changes to a system structure, and structure should be validated the same way you would validate any configuration change. When you treat verification as part of the operation rather than an optional extra, you make fewer persistent mistakes. A final safety mindset that ties these operations together is staging and reversibility, which is about reducing risk even when you cannot undo actions easily. Instead of operating directly on critical paths, you can conceptually stage changes in a safe location, confirm the outcome, and then perform the final move into place. This reduces the impact of mistakes because you are not immediately overwriting or deleting the only copy of something important. It also helps with learning, because staged operations give you a chance to observe results without causing damage. Another helpful habit is thinking about backups and snapshots as part of your safety net, especially before large reorganizations, because even careful people make mistakes, and the question is whether the system can recover from them. The exam often tests safety habits through scenario language, such as an administrator needing to move configuration files without losing a working state, or needing to remove old logs without deleting current ones. In those questions, the best answers reflect caution, explicit intent, and controlled scope. Staging, verification, and awareness of overwrite, permissions, and links are the conceptual tools that produce that caution. By the end of this episode, you should feel comfortable treating create, copy, move, and remove as controlled changes to file system objects rather than as simple user actions. Creating is about making a new object and a directory entry, and it depends heavily on directory permissions and default attribute rules. Copying is about duplicating content into a new identity, which raises questions about metadata preservation and later independence of changes. Moving is often a rename within a file system, but across file systems it behaves more like copy plus remove, which affects performance and attributes in ways exam scenarios often hint at. Removing is about deleting directory entries and potentially freeing storage, and it becomes dangerous when patterns, recursion, or mistaken paths expand the scope of what you intended. If you keep these concepts in mind and apply verification and staging habits, file operations become predictable and safe rather than stressful. That predictability is exactly what Linux Plus is looking for, because it demonstrates you can manage a Linux system thoughtfully and avoid the avoidable mistakes that cause real-world outages.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.